Hey class, this is lesson 4.7, sequences and functions. You will learn to identify and extend patterns in sequences and to represent arithmetic sequences using function notation. All right, you can go ahead and pause now and check back for the answers. All right, extending sequences. So we want to describe the pattern in each sequence and figure out what the next two terms are in the sequence. The first sequence, you probably notice those are even numbers, consecutive even numbers starting with 4. So that's what we're going to call that, consecutive even numbers. Integers. Starting at 4. And so the next number is 12 and then 14. And in the second sequence, what we have is, one way you could look at the first sequence is there's a common difference of 2. That'd be another way to describe the pattern. So a series of integers with a common difference of 2 starting at 4. This one actually has a common multiple of 3. So we're multiplying by 3. And repeated multiplication can be represented using powers. So we're going to say that this is consecutive integer powers. With base 3. In other words, I could write these also like this: 3 to the 0, 3 to the first, 3 to the second, 3 to the third, etc. So the next two numbers are 27 times 3 is 81, and 81 times 3 is 240. All right? Now this pattern is numbers that start at 5 and with a common difference of 6. So I'm going to describe it that way. Sequence starts at 5 and has a common difference of 6. So basically that means we're adding 6 over and over again. So the next two terms are 29 and 35. All right, identify an arithmetic sequence. In an arithmetic sequence, the difference between the consecutive terms is constant. So you have a common difference. Right? So if we see a common difference, we know it's an arithmetic sequence. And then soon we're going to learn how to write equations to represent that. So what is the common difference here? If it is an arithmetic sequence, so what we want to do is all right, we're going to subtract the numbers. 7 minus 11 is 4, 16 minus 11 is 5, 22 minus 16 is 6. Since these numbers are not equal to each other, there is no common difference. So we're going to say, no, it's not arithmetic. The second one, 9 minus 3 is 6, 15 minus 9 is 6, 21 minus 15 is 6. There is a common difference, so we're going to say yes. This one's arithmetic, and the common difference is 6. All right, go ahead and try that. All right, here's the rule for arithmetic sequence. If we want to make a rule where we know the first term and we know the common difference, it would look like this. A sub n, which means the nth term, is equal to the first term plus 1 less than the term number times the common difference. So if you look at the way this is set up, this is going to find the fifth term. And the common difference is 7. And the first term of the sequence is 3. If we actually wanted to write out that sequence, our first term is 3. That's given by that part. Our common difference is 7. So that means we're going to add 7. So our next term is 10, and then 17, and 24, and so on. And a sub 5 means I'm finding the fifth term. And to do that, we just have to take 3 plus 5 minus 1, or 1 less than the term number, times 7, and that's equal to 3 plus 4 times 7, which is 31, which, if we went to the fifth number here, we would get 31. So we're going to use that idea to write a rule for arithmetic sequence. So here we have Justine's grandfather puts $100 in the savings account for her on her first birthday. He puts 125, 150, 175 into the account on her next 3 birthdays. So on her first birthday, she gets 100 put in there. Her next one, 125. So this is her first birthday, second birthday, third birthday, fourth birthday, So we're going to write an arithmetic sequence for that using the formula. And the formula is a sub n is equal to a sub 1, which means the first term, plus n minus 1, n being the number, the term number, times common difference. So to write this, we need to know the first term, which in this case is 100, plus we need to know the common difference, and that is just subtract any two consecutive numbers. 175 minus 150 is 25. And if you wanted to simplify that, you could. A sub n is equal to 100 plus, if we use the distributive property here, we get 25 n minus 25, which is the same as 75 plus 25n. And then it says we want to find out how much is in saving on her 12th birthday. So we would just do a sub 12, a of 12, and substitute 12 in for n. 25 times 12, and 75 plus 25 times 12 is 375. So he's going to put $375 in the 12th birthday. Okay? And that's a wrap.